Assalamualaikum. First and foremost, my name is Muhammad Khairul Azmi bin Shahren and my supervisor is Sir Muhammad Mazwan bin Mahat. So I will present on my final year project 1, which is the experimental analysis of tribological properties on a bio-based mixed oil. Summary: vegetable oils have been considered as potential candidates for improving overall tribological performance in comparison to mineral oils. Aims: this research focuses on the experimental analysis of tribological properties on a bio-based mixed oil using a vegetable oil as an additive in developing a food-grade lubricant. Next is to evaluate the effect of vegetable oil in different concentrations towards the friction and wear behavior of the mixed oil. So what is the issues? The lack of study on the mixed oil as a food-grade lubricant and olive oil as an additive in formulating a food-grade lubricant. So why choose olive oil? It is found consisting a large number of monounsaturated fatty acids, thus has better oxidation stability which makes it suitable as a lubricant. Next, due to the availability, non-toxicity and degradability, olive oil has big potential in developing a food-grade lubricant. So the purpose is to investigate both friction and wear behavior of the mixed oil. Method used is according to the standard test method, the STM D4172 using 4-ball tester, and the expectation at the end of the experiment is the mixed oil can provide the same or better tribological performance as the industrial food grade lubricants. Lubricants are used in a variety of industries including food, oil and gas, automotive, milling and others. They play an important role in helping machinery to work effectively and smoothly since machinery movement involves friction between surfaces, wear and overheating. Lubricant leakages and maintenance are an inevitable part of all industries, thus they need to properly select the lubricants. Incidental contact between lubricants and food cannot always be fully excluded and may result in contamination of the food product. Majority of the world's lubricants are derived from petroleum-based oil. However, petroleum and mineral oil-based lubricants are thought to be harmful to humans and the environment. Vegetable oils are preferred over petroleum-based oil lubricants due to their well-known biodegradability property. In addition, vegetable oil-based lubricant is much cheaper in price relative to synthetic lubricant. Issues such as non-biodegradability and depletion of mineral oil reserve have shifted scientists and researchers' attention to renewable energy sources. The characteristics of vegetable oils that make them suitable replacement for mineral oils include renewability, good low temperature properties, biodegradability, and non-toxicity. Hence, this project will use vegetable oil, which is olive oil, as an additive for the mixed oil. As mentioned, olive oil is high in the amount of monounsaturated fatty acids. Furthermore, as a vegetable oil, olive oil is non-toxicity and degradability, thus further increase the fit in developing the food-grade lubricant. There are several studies and researches found during the literature review. Vegetable oils. Binfa et al. 2015 states that castor oil can be used as an alternative to mineral oils with the appropriate wear additive and friction modifiers due to its wear properties and lagging friction. The next example is Amit Swane et al. 2017 tested the castor oil and mahua oil samples using a 4-ball wear tester for tribological properties. The tests were performed against a standard HP90 lubricant and the 50-50 blend was found to perform well in wear scar diameter and friction parameter coefficient. Next is the olive oil, which et al. Studied on the potential positive biological and clinical aspects of olive oil-based intravenous lipid emulsion (ILE) and conclude that it is well tolerated and provides effective nutritional support to various parental nutrition, the end requiring patient populations. The number of fatty acids in extra virgin olive oils from various regions of Spain, Italy, and Portugal was researched by M.V. Alonso Garcia et al. 1993. Yujida et al. 2016 investigate the olive oil and soybean oil, medium chain triglycerides, olive oil, fish oil, SMOF, based lipid emulsion (LEs) and conclude that they provide better nutritional benefits than conventional soybean oil based LEs. From this research, it is proof that olive oil as a vegetable oil is able to provide numerous benefits, mainly in health, thus proving the suitability of it in developing a food-grade lubricant. So the problem statement and objectives. There is irrefutable evidence that food-grade lubricant is becoming more popular in the use of machines, industries, and automotives as it can provide good protections from corrosion and wear. Not to mention the characteristics which can avoid from damaging when it comes in contact with the food and materials. Nowadays, the demand for mineral lubricants in industry is growing faster each year, so the oil price has become expensive. Despite the fact that numerous studies on the tribological properties of vegetable oils and additives has been conducted, none of them report on the use of the previous state mixed oil as a food-grade lubricant. Furthermore, the use of olive oil as an additive in the formulation of food-grade lubricant has not been thoroughly researched. Hence, the initiative of this project is to produce a mixed oil with an additive that can perform as any other food-grade lubricants at a reasonable price material. So the objective of the product is to demonstrate a lubricant which is a mixed oil for the gearbox and compare the tribological characteristic with food-grade lubricant. The first objective is to determine on the coefficient of friction and the wear scar diameter of a mixed oil during the experimental analysis using 4-ball tester. The second objective is to investigate the effect of a different concentration of the additive towards the wear properties of the lubricant. Scope and limitation. The scope of this study focuses on the approach used to analyze a combination of a gear oil zinc 220 as the base oil and olive oil as an additive. Different concentration of additive where each of the performance will be tested and recorded. Second, the project will begin with a preliminary evaluation of the wear preventive properties of the mixed oil using an ASTM D4172 on a 4-ball tribo tester machine. Response surface methodology, RSM, will be used where the controlled parameters for the experiment are applied, which are the load, rotating speed, and temperature of ball cup, which will be adjusted accordingly. This experiment will focus on investigating the lubricity performance, including coefficient friction and the wear scar diameter result from the mixed oil. The limitation is that this experiment will only be held in the tribology lab in UiTM Shah Alam with a limited 4-ball tribo tester machine. Furthermore, during the course related to the lab of machines, the students will have more priorities compared to our final year project. Methodology of this project. First is reviewing several articles and journals to find the suitable characteristics of additive in developing a food-grade lubricant. So here, I choose olive oil as an additive during the literature review. So next is the preparation of the lubricant and the test balls. The lubricant preparation is the gear oil zinc 220 mixed with different concentrations of olive oil, which is 3 samples. Next is purchasing the test balls according to the ANSI standard with a diameter of 12.7 mm and hardness is 64 to 66. And if both of the preparation follows the specific composition, we will go to the preliminary evaluation where the tribological test using 4-ball tribo tester experiment will be held. So here the apparatus and the procedure will be done accordingly. So the wear and surface result will be achieved, and if the result is reliable, thus the wear scar diameter and the coefficient of friction data will be analyzed. So the wear scar diameter will be analyzed using the microscope provided by the 4-ball tester machine. For the expected results, I am sadly informed that our lab assistant was involved in an accident and rested for about 3 months. Hence, the preliminary result was not achieved. Therefore, here are the expected results gained from during the literature researches related to the topic tribological and thermal properties of natural oils as sustainable biolubricants. We can see from the graphs that among the vegetable oils, olive oil successfully results in low wear and coefficient friction. Hence, from these results, it is expected that olive oil can provide good tribological properties which are low in friction and wear in developing a food-grade lubricant. That's all from me. Thank you.